There is a date in your head. You might have never consciously articulated it, but it is there, somewhere between what you learned in school and what you remember from documentaries you watched on a Sunday afternoon. The date says 200,000 years. That is where everything began, according to what you were told. Somewhere in East Africa, in the Great Rift Valley, a species emerged. It was called Homo sapiens. That was 200,000 years ago. This date is wrong. Not slightly wrong, not a rounding error wrong, by at least 100,000 years. And it isn't the only thing you've been told about your origins that deserves to be reconsidered tonight. Settle in. Rest your head. What you are going to hear tonight isn't a textbook revision. Oh, it is something much stranger than that. The story of an immense void, of a darkness spanning hundreds of thousands of years that science still doesn't fully understand. The story of what we were before we became what we are. And, perhaps the most surprising story of all, what we are still discovering about ourselves. Before we go any further, I would like to know where you are listening from tonight. New York, California, Texas, the UK, Australia, or maybe somewhere else, somewhere in the world I haven't named. Tell me in the comments if you feel like it, and if this question has ever crossed your mind. If you too have ever wondered where your species truly comes from, at what exact moment someone like you began to exist, leave a comment. I would genuinely love to read your response. And if you haven't already, take a second to subscribe. It helps me continue doing this work. Now let's find ourselves in a mine in Morocco. In 1960, the workers toiling in the barite mine of Jebel Irhoud, about 60 miles east of Marrakesh, weren't looking for ancestors. They were looking for ore. The site was unforgiving. Galleries carved into limestone, a dry heat, a white dust that settled over everything. And sometimes, when they blew up a block of stone, something else would appear. Bones, bizarre shapes in the rock, things they didn't quite know what to do with. In 1961, a human skull was discovered in the cavity, partially fragmented. No one really knew what to make of it at first. The skull was sent to researchers. It was roughly dated to a fairly recent era. It was placed into a blurry category. Perhaps an archaic Homo sapiens, perhaps an African Neanderthal, perhaps something else. And then it went into a drawer for decades. Jean-Jacques Hublin had a quiet obsession with this skull. The French paleoanthropologist, then at the Max Planck Institute for Evolutionary Anthropology, kept coming back to the Jebel Irhoud fossils in his work. Something was off about the available dating. Something in the morphology of the skull, that strangely flattened face, that forehead still slightly receding, yet that general shape of the posterior skull that looked familiar but didn't fit the established categories. It wasn't until 2004 that new excavations seriously began, and for the results to come out in the journal Nature. The date was 315,000 years. Take a moment with that number. 315,000 years represents about 4,000 human generations. If each generation occupied a page of a book, that book would be 4,000 pages long. And these fossils, these men and women whose jaws, skull bones and teeth were found at Jebel Irhoud, were, according to all available analyses, Homo sapiens. Not pre-sapiens, not almost sapiens, recognizable members of our own species, give or take a few details. 115,000 years older than what you knew. And that isn't all. The Jebel Irhoud fossils didn't come from East Africa. They came from Morocco, from the northwestern part of the African continent, over 6,000 miles as the crow flies, from the Ethiopian and Kenyan sites that figured in every textbook as the cradle of humanity. What this discovery suggests, and what most researchers accept today, is that Homo sapiens was not born in a single place. There was no one cradle, there was no single valley, no founding tribe, no first morning. The emergence of our species happened across the entire African continent, in populations that lived separately, occasionally came together, exchanged genes, and evolved in parallel. A distributed, fragmented, slow process. Not a birth, but rather a long germination across an entire continent. Hublin described the individuals of Jebel Irhoud as the first glimmerings of Homo sapiens across the African continent. It is not the metaphor of a sunrise in one specific spot. It is the light rising everywhere at once, unevenly, progressively. Imagine them, a few individuals in this region of what is now Morocco. They made flint tools, fine blades chipped with care. They hunted. Perhaps they cooked their food. Their faces, if you pass them on a street today, would seem slightly strange to you. That forehead a little lower, those brow ridges a little more pronounced, that skull slightly more elongated toward the back. But their eyes would recognize you. That is the strangeness of Jebel Irhoud, not the difference, but the resemblance. There is a detail in this story that deserves to be told, because it says something important about how science works, or rather, how it stumbles. The original skull discovered in 1960 was mishandled during its first analyses. The techniques available at the time simply weren't up to the task, so it was believed to be recent. 20, 30, maybe 40,000 years old. And because it was too recent to be interesting within the framework of the theories of the time, it was filed away, forgotten, under-analyzed for decades. One of the greatest discoveries in the history of paleoanthropology stayed in a drawer because we didn't have the right tools to read it. How many other drawers exist? How many other crates in how many other museums contain misclassified, misdated, misunderstood bones, just waiting for a researcher to come back and look at them with new eyes? The question isn't rhetorical, it is central, because human prehistory is not a book already written that we are simply reading. It is a book we are writing, page by page, bone fragment by bone fragment, genome by genome. And sometimes a single page is enough to rewrite everything. Now, there is one thing I want to correct tonight because it is still in a lot of heads. The idea that human evolution looks like a straight line. You have probably seen that drawing, a silhouette leaning to the left that gradually straightens up until the upright man on the right. Australopithecus gives way to Homo habilis, who gives way to Homo erectus, who gives way to Neanderthal, who gives way to you. An orderly succession, a march toward perfection. This image is a fiction. At the time the individuals of Jebel Irhoud were living in Morocco, there were perhaps 8 or 9 distinct human species alive simultaneously on Earth. Homo Naledi in South Africa, populations of Homo erectus in Asia, ancestors of the Neanderthals in Europe, beings we haven't even named yet, whose existence we are only beginning to suspect through genetic signals. Not a line, a thick bush. Branches that cross, merge, die out, reappear. We are not the pinnacle of a pyramid. We are the sole survivor of a very large family. It is both humbling and extraordinary. There is one more thing to grasp before we continue, and it is perhaps the most unsettling. The individuals of Jebel Irhoud had our anatomy more or less. They had our cranial capacity. They made tools. But if you look in the archaeological record for traces of what we call modern behavior, art, jewelry, complex funerary rituals, abstract symbols, narrative thought, you won't find them yet. Not at this time, not on this scale, not continuously. These beings who look like you lived without leaving the kind of traces we associate with being fully human for 200,000 years. 200,000 years of cultural silence, or at least silence in our records. 200,000 years where something was perhaps slowly brewing without yet leaving the footprints we know how to recognize. It is this void that will occupy us tonight. This immense, magnificent and troubling void between the human body and the human soul as we know it. Jebel Irhoud answered one question. When did we appear? And it opened a much larger one. What did we do next for so long in that darkness about which we know almost nothing? Rest your head. The silence is beginning to speak. There is something strange in the idea that beings who looked like you lived over 300,000 years ago, and that almost nothing of what they thought, nothing of what they felt, nothing of what they perhaps wanted to pass on has survived. Just bones and an immense void after them. It is toward this void that we are going now. The silence of the 200,000 years. 315,000 years ago, that is where you begin, according to what the fossils of Morocco have taught us. You have your anatomy, more or less, your bones, your cranial capacity, and yet, and this is where something strange enters the room, if you look at the archaeological record for those hundreds of thousands of years that follow, you find almost nothing that resembles the way we live today. No continuous art, no documented funerary rituals with any certainty, no clearly tailored clothing, no villages, no long-distance trade of symbolic objects, no flutes, no figurines, no paintings on walls, just flint tools, the remains of fires, animal bones, and the immensity of passing time. 200,000 years, perhaps 250,000. To give a measure to this silence, the entirety of written human history, from the first Sumerian tablets to today, represents about 5,000 years. This behavioral void is 50 times longer than everything we have ever written down. 50 times the duration of all known civilizations stacked one on top of the other. Passed in the darkness, leaving no readable trace. Why that is the central question of this chapter. And I will be honest with you right from the start. No one has a definitive answer. Researchers have hypotheses, several solid hypotheses. They are not all mutually exclusive, but none closes the case. Let's start by setting something straight in our minds. The idea that the humans of this era didn't think, that they were some sort of biological robots, bodies without interiority, is probably false. Their brains were the same size as yours. Their laryngeal anatomy likely allowed for a certain level of vocal communication. They lived in groups. They cared for their wounded. We have found fossils showing individuals who survived severe trauma, which implies prolonged care. They were not empty. So what was happening? The first and simplest hypothesis is called preservation bias. What we don't find might simply not have existed, or perhaps we just aren't looking in the right places. The vast majority of prehistoric African sites have not yet been excavated. Organic materials, worked wood, tanned hides, braided cords. Wooden structures decompose in a few thousand years in humid conditions. What survives for archaeology is stone. And even then, only certain types of stone in certain types of soil, under certain conditions of temperature and humidity. Everything made with perishable materials. And in modern traditional societies, that is, the vast majority of objects, has vanished without a trace. It is possible that the humans of this era had complex cultural practices, that they told stories, that they performed rituals, that they made beautiful things with feathers, plant fibers, pigments on their skin. All of that would be long gone. What we call silence is perhaps simply the result of what the earth keeps and what it erases. It is a reasonable hypothesis, but it doesn't explain everything. Because when something does survive pierced shells, engraved ochre traces of red pigment, we find them in flashes, intermittently. They appear, then disappear from the records for tens of thousands of years, then reappear elsewhere. Not a continuous tradition, flashes of lightning. This pattern has a name in the scientific literature. It is sometimes called behavioral modularity. The idea that modern behaviors didn't appear all at once in a sudden cognitive revolution, but emerged piece by piece in different places at different times and often without being passed on to other groups, often without enduring. Can you imagine that somewhere in South Africa, 100,000 years ago, a group of about 50 people developed a practice? Perhaps piercing shells to make ornaments, perhaps engraving ochre with repeating patterns. This practice existed for a few generations, and then something changed. A drought, a forced migration, an epidemic, or simply the disappearance of that small group. The practice died with them. It was not passed on, because cultural transmission, the ability to pass complex learning from one generation to the next through language, formal teaching, symbols, and stories, is perhaps itself something that was built progressively and not in a straight line. The second major hypothesis revolves around demographics. For the vast majority of this period, human populations in Africa were probably very small and highly dispersed. We might be talking about a few tens of thousands of individuals for the entire continent, scattered in small bands of 20 to 50 people. Groups that rarely met, that exchanged little, that developed local solutions to local problems, and that simply didn't have networks dense enough for innovations to spread and accumulate. Cultural accumulation, the fact that each generation builds upon what the previous one has learned, requires a certain population volume and a certain level of connection between groups. Below a certain threshold, good ideas die with their inventors. This has sometimes been compared to trying to pass a flame from one candle to another. If the candles are too far apart, the flame dies in the space between them. There is genomic data that supports this idea. Analyses of ancient DNA suggest that certain periods of African prehistory saw significant reductions in population size. Not necessarily sudden catastrophes, but prolonged periods of contraction followed by expansion. Cycles of scarcity and abundance over millennia. And then a third path, the climate. Africa during this period was not the continent we know today. It oscillated between humid and arid phases, sometimes very rapidly on a geological scale. The Sahara today, a desert, has been green and crossed by rivers multiple times. The equatorial forests shrank and then expanded. Coastlines shifted with sea levels. Habitable regions became inhospitable, then habitable again. These climatic variations could have done something important. They would have isolated populations from one another for millennia. Groups stranded in climatic refuges surrounded by deserts or water, only to be brought back into contact when conditions improved. These moments of contact would be moments of genetic and cultural mixing. These moments of isolation would be moments of silent divergence. And the whole process would produce exactly the pattern we observe: flashes of innovation, followed by disappearance, followed by re-emergence elsewhere. We must pause here on what specialists sometimes call the cognitive revolution debate. On one side, there are those who maintain that something decisive happened, a mutation, a neurological threshold, a shift in the structure of brain connections somewhere between 70 and 50,000 years ago. Something that truly transformed the human brain and allowed for a sudden explosion of symbolic capacity. Yuval Noah Harari popularized this idea in his book Sapiens under the name of the cognitive revolution. A pivotal moment when humans could suddenly talk about things that didn't exist, invent fictions, and coordinate large communities around shared beliefs. On the other side, researchers like Francesco De Rico, Christopher Henshelwood, or Sally McBrearty argue that the evidence points instead to a slow, gradual, non-linear emergence, and that the appearance of a revolution 50,000 years ago is mostly an artifact of the European archaeological record. Because Europe is the most heavily excavated continent, and it is where traces have been best preserved. Both camps have solid arguments, and the truth likely lies in that uncomfortable middle ground where science often resides. Neither a sudden revolution nor a simple linear accumulation, but something more complex. Capacities that emerge in local contexts, that are lost, that are reactivated, and that eventually reach a critical mass. There is a detail in all of this that touches me in a particular way, and I am going to tell you simply. Imagine a woman or a man living 150,000 years ago in what is today South Africa. She has your cranial capacity. Her hands are the same as yours. She has the same neural connections, broadly the same capacity for learning. She looks up at the same night sky. She perhaps feels the same vertigo before the stars. And yet, nothing of what she might have felt or thought. No dream, no question, no attempt to understand the world in which she lived has reached us. This void between her inner life and our memory of that life is perhaps the most profound form of loneliness that exists. Not hers, ours. The fact that we cannot reach her. And yet, and this is why tonight is worth listening to until the end, a few traces have survived. Not many, but enough to know that someone was there. A few pierced shells in Israel and Algeria 120,000 years ago. Blocks of engraved ochre in South Africa 100,000 years ago. Carefully constructed hearths, flints chipped with a precision that exceeds what simple utility demands. Someone held those shells, someone chose them, pierced them, perhaps wore them. Why? We don't know. But someone did it. It is in this almost nothing that everything begins. These pierced shells, these shards of ochre, someone made them within a group, surrounded by other people. And the other people living in that era were not always like them. The earth was inhabited by others, other humans, beings we haven't even suspected yet. And one of them was discovered thanks to something infinitely small, a bone fragment that a little girl left in the soil of a cave in Siberia 60,000 years ago. The pinky finger that changed everything we thought we knew. What the bone fragment left by that previous group, those few flashes of existence in the great silence, means is that prehistory was not empty. It was populated. not just by our direct ancestors, but by others. Here is a fact you might know. In 2010, a team of geneticists in Leipzig sequenced the DNA from a tiny bone fragment found in a cave in southern Siberia. This fragment came from the pinky, the little finger of an individual's hand. It measured about 2 centimeters. It was roughly 50 to 80,000 years old. And it was going to change the way we understand the history of humanity as profoundly as any discovery in the last 50 years. What the team expected to find was Neanderthal or Homo sapiens DNA. Those two were the logical candidates for a Siberian cave of that age. Svante Pääbo, the Swedish geneticist directing the laboratory, who would receive the Nobel Prize in 2022 for his work, was used to working with degraded ancient DNA, reconstructing genomes from minuscule fragments. His team had already sequenced Neanderthal genes. He knew what the genetic signature of a Neanderthal looked like. What they found in the Siberian pinky finger didn't look like anything known. It wasn't a Neanderthal. It wasn't a sapiens. It was something else. Something that had diverged from the Neanderthal lineage about 400,000 years ago. Something that had coexisted with Neanderthals in Eurasia for hundreds of thousands of years, and of which no one knew anything, because no one had ever looked in that direction. A third, entirely unknown human species, discovered not by a spectacular bone, not by a skull, not by a complete skeleton, but by a molecule of DNA in a pinky fragment. They called them the Denisovans after the Denisova cave in the Altai mountains of Siberia, where the fragment had been found. Imagine the Denisova cave. It is nestled in a rocky gorge, halfway up a mountain covered in larch and pine forests. It is cold. In winter, temperatures regularly drop below -4 degrees Fahrenheit. The rock is limestone, which helps preserve bones. The cave has 3 chambers. Humans of different species clearly stayed there at different times, over tens of thousands of years. It was a place of transit, perhaps, a seasonal refuge, perhaps more. And the little girl the pinky belonged to, genetic analyses suggest it was a female individual of about 13 years old, had lived there or nearby. She died. Her pinky was fragmented, buried in the sediments of the cave. For 50 to 60,000 years, under layers of dust and clay and accumulated debris, her DNA waited. It is a thought that stops you in your tracks. An entire human species, a species that had populated, as we would later discover, an immense portion of Asia, from Siberia all the way down to the Philippines for perhaps 500,000 years. All that history, all that existence, summarized for posterity in a bone fragment no larger than the last joint of your little finger. What followed the initial discovery in 2010 was an extraordinary decade of genomic investigation. Researchers began looking for traces of Denisovans in the genomes of modern human populations. And they found them in proportions that were unevenly distributed, but impossible to ignore. Melanesians. The inhabitants of Pacific islands like Papua New Guinea, the Solomon Islands and Fiji carry up to 5% Denisovan DNA in their genomes. Indigenous Australians carry roughly the same proportion. The Negritos of the Philippines, indigenous populations like the Aita Magbucon, carry perhaps 6%. Populations in Southeast Asia and East Asia carry between 1 and 2%. Tibetans carry a smaller amount in volume, but of considerable functional importance. Because Tibetans, and this is one of the most astonishing facts to come out of this discovery, carry a version of a gene called EPAS1 that comes directly from the Denisovans. This gene regulates hemoglobin production and the body's response to low oxygen levels. It allows Tibetans to live comfortably at elevations of 13 to 16,000 feet, in conditions where most other human beings suffer from altitude sickness, where muscles lack oxygen, where the brain begins to malfunction. This remarkable physiological adaptation is not the product of Homo sapiens evolution alone. It is an inheritance, a genetic gift from a species that spent hundreds of thousands of years in the highlands of Central Asia, developing solutions to problems that newly arrived sapiens did not yet know how to solve. The Denisovans are extinct, or at least there are no longer individuals who can call themselves Denisovan. But their biology still lives. In the lungs of shepherds on the Tibetan plateau, breathing the thin air at 16,000 feet, there is something that belongs to a species that vanished tens of thousands of years ago. We must now talk about what we do not yet know and what we began to understand in 2025. For more than a decade after the initial discovery, Denisovans remained an abstraction. We had their DNA, we had a few pinky bone fragments, a few teeth, a skull fragment found later in the same cave, but no image of them, no face, no idea of their general morphology. Then, in 2025, things started to change. A skull found in Harbin in northeastern China, known for decades as the Dragon Man, a massive, almost overwhelming skull in its proportions, with one of the largest cranial capacities ever measured in a hominin, was linked to the Denisovans through an analysis of mitochondrial DNA extracted from the temporal bone. It was at least 146,000 years old, the largest archaic human skull known. And it belonged, with all the necessary caution still required, to this group we only knew as a genetic trace in Siberian pinkies. For the first time, the Denisovans were beginning to have a face. A massive face, with prominent brow ridges, a wide jaw, a high forehead, different from Neanderthals, different from us. A face that had looked up at the sky of China 146,000 years ago, that had breathed, thought something, lived. A face no one had expected to find in any of the established categories. There is a point of disagreement in the scientific community that deserves to be named directly. Some researchers, including Chinese specialists, assert that the identification of the Harbin skull as Denisovan is not yet definitively established. Mitochondrial DNA represents a single line of maternal descent. It does not capture the full genomic complexity of an individual. It is possible that the Harbin skull represents a partially distinct species, or a local population that had ties to the Denisovans without being identical. Other researchers, however, consider the evidence convergent enough to establish the link with confidence. The debate continues. What is certain is that in 2025, the Denisovans began to step out of the genomic shadows to enter the world of faces and bodies. And now think about this. 17 years ago, we didn't know they existed. 15 years ago, we didn't know they had left genes in living populations. 10 years ago, we didn't know they had populated Southeast Asia all the way to the Philippines. 2 years ago, we didn't yet know that one of them had perhaps the largest archaic human skull ever found. All this knowledge came out of a pinky fragment in a Siberian cave. And now a question I want to leave hovering in the air before moving on. There were the Neanderthals in Europe. There were the Denisovans in Asia. There were the sapiens in Africa. There were, as we will learn later, others still. But genomic analyses have revealed something even more unsettling, something that has no name, no cave, no identified fossil, no massive skull found in a museum drawer in China, a presence in our genes without a face or a tomb. And that is where we are going now. What the Denisovan Pinky opened was a door to the invisible. Species that existed without leaving identifiable bones, but that still live in our genomes like a fingerprint we are just beginning to read. The Siberian cave taught us to look further. And when geneticists looked further, they found something that, for now, still has no face. 20% of you comes from someone we have never found. The door that this Siberian cave opened doesn't just lead to the Denisovans. It leads to something vastly larger and even more unsettling. A space in our own biology that belongs to a faceless presence. You carry within you right now DNA sequences that do not come from Homo sapiens. They do not come from Neanderthals. They do not come from Denisovans. They come from someone else, a population of which no archaeologist anywhere in the world has ever held a bone in their hand with certainty. They are called a ghost lineage. This name is both precise and uncomfortable. Precise because it describes exactly what it is, a presence that genetics clearly detects as a fingerprint in the sand, but whose author has left no identifiable body. Uncomfortable because population genetics is quite formal about this. This footprint is real. It doesn't look like a statistical artifact. It looks like a real population with its own characteristics that lived, crossed paths with our ancestors, and disappeared. In March 2025, a team of geneticists published a study in the journal Nature that sent shockwaves through the paleoanthropological community. Their genomic model, built from the analysis of hundreds of modern and ancient human genomes, suggested something very specific. About 1.5 million years ago, a population evolving on the lineage leading to modern humans split into two groups. One group continued on a trajectory that would hundreds of thousands of years later produce the direct ancestors of all humans living today. The other group went in a different direction, lived separately, evolved separately for more than 1 million years. Then about 300,000 years ago, the two groups met again. They crossed paths, interbred, merged. And this fusion, according to the model, contributed about 20% of the DNA to the ancestors of all modern humans. 1/5 of you. Not a tiny trace, not 2 or 3%, 1/5. And this 20% might not be neutral. The model suggests that this fusion coincides with a period of expansion in cognitive capacities within the human lineage, an acceleration of brain development perhaps, a reorganization of certain neural circuits. It isn't proven causally, but the temporal coincidence is striking. The encounter with this mystery population happens right at the moment the Jebel Irhoud fossils come to light, right at the moment when something in our lineage seems to change. Who were they? That is the question everyone is asking, and honestly, we don't know. The possible candidates based on chronology and geography include species we have named but understand poorly. Homo heidelbergensis. Homo antecessor populations of late Homo erectus. Perhaps a combination. Perhaps none of these names truly apply. Perhaps it is a species not yet described in the fossil record, whose bones we simply haven't found yet in the right geological layers in the right regions. Genetics in this case runs faster than archaeology. This imbalance is itself revealing. For decades, paleoanthropology was built on fossils. You name a species when you have a bone. You establish a relationship when you can compare morphologies. But ancient genomics has profoundly changed the rules of the game. Today, we can detect the presence of a population in human evolutionary history without having a single one of its bones. We can map its contributions to our biology without ever having seen it. It is both a scientific revolution and a philosophical vertigo. There is something I want to bring up here because it isn't often stated clearly. The geneticists working on these models are the first to insist on their limits. A genomic model is not a fossil reality. It is a mathematical reconstruction of what might explain the patterns observed in the current data. Other models with other hypotheses could perhaps produce similar results. Science is actively debating the robustness of these conclusions. What the 2025 model asserts with the most confidence is the reality of the separation and the reunification. Two populations diverging, living separately, and finding each other again. The consensus is broad enough to support that. The exact nature of the returning population, the details of its contribution to our cognitive capacities, all that remains under discussion. And that is exactly where the honesty of science resides on this subject. No premature certainties, but a signal strong enough that it cannot be ignored. Now think about what that means in concrete terms. Somewhere in your genome, in the millions of base pairs that make you up, there are sequences that were shaped during 1 million years of separate evolution by a population we have never met. One that left us no painted wall, no tomb, no clearly identifiable tool. One that melted into our ancestors like a river into a greater stream, leaving its water, its color, perhaps its temperature, but no shores of its own. There is an image in this story that stays with me. 300,000 years ago, at the moment of this fusion, according to the model, somewhere in Africa, two groups of humans who had not seen each other for a very long time, perhaps for generations, perhaps for centuries of climatic separation, found each other. They had no established common language. Perhaps they had slightly different decor, slightly different ways of working, stone dietary habits shaped by different environments, and yet they recognized themselves in one another, enough to have children together, enough for their biology to merge. We cannot know if these encounters were violent or friendly. Probably both, depending on the occasion. Probably the whole human spectrum of encounters between different groups. But something biological and profound was passed on, and the result of these forgotten encounters is living right now in the neurons processing these words as you listen. The boundary between us and the others in human prehistory is much less sharp than we believe. It has always been porous. It has always let something through. What genomics ultimately teaches us is that humanity has never been a pure thing. It has always been a mixture, a network of confluences, rather than a single river. And the ghosts of these confluences, these populations without faces, without names, without tombs, continue to circulate in our arteries and our synapses long after everything else about them has disappeared. Something in the way you think tonight, something in the connections forming in your brain right now as you listen to these words, perhaps carries the mark of people who lived under an African sky 1 million years ago, and of whom we have absolutely no memory. Rest your head gently on that thought. These faceless populations merged with our ancestors. But other things in prehistory nearly erased everything. 74,000 years ago, the Earth itself trembled in a way we still struggle to imagine. And a long dominant theory held that this event nearly reduced all of humanity to a few thousand survivors. This theory is being questioned today, but the void it leaves behind is perhaps even more unsettling than what it proposed. The volcano that almost erased everything, or perhaps didn't. These populations without clear borders, these lineages crossing in the darkness of prehistory, all of this might never have produced anything at all if the Earth had been in a slightly more sustained bad mood. Here is the scale of the problem. 74,000 years ago on the island of Sumatra in Indonesia, a volcano did something that volcanoes almost never do. It didn't just erupt. It collapsed in on itself, sucked its own magma into an empty chamber, and exploded with a violence that very few geological events in the history of the Earth can equal. Mount Toba. Today, a tranquil caldera lake 60 miles long in northern Sumatra projected about 670 cubic miles of ash, sulfur, and debris into the atmosphere. To give you an idea of what that represents, Mount St. Helens in 1980 ejected about a quarter of a cubic mile. Mount Pinatubo in the Philippines in 1991, one of the largest eruptions of the 20th century, ejected about 2.5 cubic miles. Toba. The Indian subcontinent was covered in a layer of ash 4 to 6 inches thick over an area the size of Western Europe. Sulfurous aerosols were injected into the stratosphere and circulated for months, blocking a portion of the sun's light. Global temperatures likely plummeted by 5 to 9 degrees Fahrenheit for several years. In certain regions, perhaps a decade of cooling. It is what geologists call a volcanic winter. The hypothesis formulated by paleoanthropologist Stanley Ambrose in 1998 was seductive in its dramatic simplicity. This volcanic winter caused massive collapses of tropical vegetation. Prey vanished, food resources plummeted. Human populations, already small and dispersed, were reduced to catastrophic levels. Perhaps 10,000 individuals, perhaps fewer. A genetic bottleneck so severe that all the diversity accumulated over hundreds of thousands of years was compressed into a minuscule residue. This idea that all of humanity nearly vanished in the ashes of Toba became popular. It was relayed in hundreds of articles, repeated in documentaries, cited in textbooks. It had an irresistible narrative force. The species on the edge of the precipice, saved by a hair's breadth, marked forever in its genes by the brush with extinction. The problem is that the evidence doesn't entirely support it. In India, archaeologists have excavated sites where layers of Toba ash are clearly visible in the sediments. And on either side of that layer, before and after the eruption, the stone tools are almost identical. Same technology, same knapping style, same type of weapons. There seems to be no break in the populations that made these tools. They continued before and after without notable interruption. In South Africa, in sites like Pinnacle Point, cave analyses show that coastal populations not only survived the Toba period, but seem to have maintained complex cultural activities during and after the eruption. No sign of the catastrophic collapse that Ambrose's theory would predict. These discoveries have led many researchers to conclude that Toba, while devastating for certain plant and animal species, did not cause the human genetic bottleneck attributed to it. But, and this is where things get truly interesting, the genetic bottleneck exists anyway. DNA analyses of modern human populations clearly reveal a reduction in genetic diversity that occurred somewhere between 70 and 100,000 years before our era. Human populations at that time were very small, perhaps 10 to 30,000 individuals in total across the entire world for a prolonged period. This demographic pressure is written into our genomes with an almost uncomfortable clarity. If Toba didn't cause it, what did? We don't know. It is one of the most important open questions in human prehistory. An event, or perhaps a combination of several gradual events, reduced humanity to a small core of survivors. Perhaps a prolonged period of drought in Africa. Perhaps a series of cumulative minor volcanic eruptions. Perhaps a combination of climatic pressure, epidemics, and competition with other species. Perhaps something we haven't even identified yet in the geological record. Humanity almost disappeared. Something almost erased us, and we still don't know exactly what it was. There is something in this uncertainty that deserves to be held for a moment, without trying to resolve it too quickly. Imagine the Earth 75,000 years ago. African tropical forests shrinking, arid plains, and human groups isolated from one another. Perhaps 30 or 40 groups across the entire continent, each counting a few dozen individuals, living in pockets of habitability separated by inhospitable expanses. Without contact, without exchange, perhaps without even knowing that others existed. In each of these groups, children were born. Elders died. Stories or something resembling stories were perhaps passed down around the fires. Habits were established, particular ways of shaping stone, of choosing food, of caring for the sick. And in each of these groups, the horizon of extinction was perhaps close. A group of 20 people only needs one bad season, one epidemic, an increase in predation to disappear entirely. 20 people is as fragile as a flame in the wind. We come from there, from those flames, from those pockets, from those few dozen groups that held on, that survived what many of their contemporaries did not. Not necessarily because they were the smartest or the strongest, perhaps just because they were lucky enough to be in the right place with the right resources at the right time. Luck plays a role in evolution that we prefer to underestimate. There is one last point about Toba I want to mention, because it illustrates something important about how science works. Ambrose's theory dominated for 20 years. It was in the textbooks, it was in our heads, and then evidence accumulated that challenged it, and researchers changed their minds. Not unanimously, not overnight. Some still defend modified versions of the theory, but the consensus evolved. This movement, an idea capturing the imagination, spreading and then being challenged by field evidence, is not a failure of science. It is exactly how science is supposed to work. The discomfort comes from the fact that we would prefer the answers to be stable, but answers are only stable when the evidence demands it. And regarding human prehistory, the evidence keeps arriving. What Toba ultimately leaves us with is not an answer. It is a more precise question. What, in that dark period between 100,000 and 70,000 years before our era, nearly erased us? And what allowed a few dozen groups to hold on to survive to continue? We don't know yet. But the flames held, and you are here to prove it. These flames that held these few surviving groups in the darkness were not the only human beings on Earth. All this time, others existed. Some in the caves of South Africa, with brains much smaller than ours doing things we were perhaps still far from imagining. Something that, if the evidence is confirmed, could radically change our definition of what it means to be human. Homo Naledi. Or what is a human being? These flames holding in the wind, these reduced, dispersed populations surviving in pockets of habitability were not alone on the African continent. Something else lived there too. Something that since its discovery has ceaselessly asked a question that science still doesn't quite know how to answer. The question is simple. The answer is not. What makes a human being? In September 2013, Lee Berger, a paleoanthropologist at the University of the Witwatersrand in Johannesburg, received a message from two amateur cavers in the hills northwest of the city. They had found something in a cave system known as Rising Star. Bones. A lot of bones. But the passage leading to the chamber where they lay was extraordinarily narrow, about 7 inches at its tightest point. No one of a normal adult height or weight could get through. Berger did what few scientists would have done in that situation. He posted a call on Facebook. He was looking for scientifically qualified cavers, preferably with a background in archaeology or anthropology, who could fit into extremely confined spaces, who could work 100 feet underground in the dark, who were not afraid of enclosed spaces. Within days, he had hundreds of responses from around the world. He put together a team of 6 women, the underground astronauts, as the press called them, who could slip through the passage nicknamed the Superman Squeeze. They descended into the cave through a vertical shaft, then crawled for dozens of yards through increasingly narrow galleries to reach the chamber. What they found there exceeded all anticipation. Bones. Hundreds of bones. At least 15 different individuals, according to initial analyses. Men, women, children, adults, the elderly. The bones were not the result of a predator dragging prey into the cave. There were no animal tooth marks, no signs of dragging or flooding that would have washed bones together by accident. The bones seemed to have been placed there deliberately. The species was named Homo Naledi. Naledi meaning star in Sesotho and Setswana languages of South Africa, in reference to the name of the Rising Star cave. And Homo Naledi was strange. Its brain measured between 460 and 610 cubic centimeters. For comparison, the modern human brain is about 1,300 to 1,500 cubic centimeters. A chimpanzee's brain is about 350 to 400 cubic centimeters. The brain of Homo naledi was therefore significantly larger than that of a chimp, but barely more than a third of ours. It has often been said it was the size of an orange. That is roughly accurate. And yet, and this is where the strangeness begins, its hands were almost human, its feet were almost human, its way of walking was almost human. Certain features of its skull recalled our own traits. Others seemed archaic, 2 million years old. Naledi was an anatomical mosaic. Ancient in some aspects, surprisingly modern in others, fitting into none of the established categories. The initial dating produced an additional surprise. One might have expected a species so anatomically primitive to be very ancient, perhaps 2 or 3 million years old. The results showed between 235 and 296,000 years before our era. Homo naledi lived in South Africa at roughly the same time as the Jebel Irhoud individuals in Morocco, at the same time as the direct ancestors of all modern humans. A species with an orange-sized brain living at the same time as us. And now the part that truly shook the field. In 2023, and then in work published in September 2025, the Rising Star team presented what they interpret as evidence of intentional burial by Homo naledi. In the Naledi chamber of the cave system, meticulous analyses of the sediments show structures that look like graves dug into the floor. Depressions in which bodies seem to have been deliberately placed in specific positions. There are traces of what might be engravings on the nearby walls. There are contested but persistent hints of the use of fire. If all this is confirmed, and I emphasize the if because the debate is far from closed, then Homo naledi, with its orange-sized brain, practiced funerary rituals. It laid its dead to rest. It perhaps marked surfaces for reasons that go beyond mere utility. The controversy in the scientific community is real and profound. A group of researchers, including Lee Berger himself, who defends his conclusions with a conviction his colleagues sometimes find excessive, maintains that the evidence is solid and the interpretation is self-evident. On the other side, respected paleoanthropologists like Maria Martinon Torres, Christoph Zollikofer, or Tim White have expressed significant reservations. The structures interpreted as graves could be of geological rather than intentional origin. The engravings could be accidental marks, and the lack of a clearly established stratigraphical context makes the conclusions difficult to evaluate independently. The question will be settled or will remain open as new analyses and excavations bring in additional data. It is not a resolved issue. But I want to pause on what it would imply if it were true, because the philosophical stakes go far beyond the technical question of dating or geological interpretation. Homo Naledi, with its orange-sized brain, a brain whose structure only roughly resembles ours, developed something akin to an awareness of death. A feeling that death deserves a ritual response, and that the bodies of loved ones deserve to be treated with particular attention rather than simply abandoned. If so, this behavior does not belong specifically to our brain size. It is not the exclusive product of the cortical complexity we believe is necessary. It would be something else. Something much older in the biology of certain living beings, something that perhaps doesn't need a large prefrontal cortex to exist. This possibility is philosophically dizzying. We tend to define humanity in the broadest sense of the term, by the awareness of death and the ritual response it produces. Religions, funerals, tombs, monuments, pyramids, cemeteries, all of this stems from the same reality. We know we die, and we do something with that knowledge. It is one of the traits we consider most specifically human, and Homo Naledi was perhaps doing it too, with a brain the size of an orange. There is a detail from the Rising Star excavations that comes back to me regularly. The teams working in the Dinaledi chamber descended every day into that darkness. The electrical grid installed for the occasion, the headlamps, the heat of the earth around them. And they were excavating floors where someone, perhaps a group of beings with brains much smaller than theirs, had laid their dead to rest 240,000 years ago. There is a continuity in that image that takes time to measure. 240,000 years of someone who perhaps did not want their dead to simply be forgotten in the dark. And now, very gently, the questions broaden even further. Because if Homo Naledi performed funerary gestures, they were not alone in this capacity. At the same time, and even well before, another human species lived in Europe and Asia with a brain slightly larger than ours, burying its dead for at least 100,000 years with certainty. A species that for a century we turned into the symbol of primitive brutality. It is time to correct this mistake. What Homo Naledi places in our minds tonight, this question about what makes a human being, this uncertainty about where consciousness begins and where ritual is born, does not disappear with the chapter. It travels with us, because the species we are going to meet now performed the same gestures with even greater clarity. And for a century, we preferred not to see it. The Neanderthals never really disappeared. The question Homo Naledi leaves hanging in the air, where does consciousness begin? Where does ritual begin? Where does what we call humanity begin? Is exactly the question the Neanderthals have been asking since their discovery. Except, with them, it took us a century and a half to start listening. Here is something you might carry within you without knowing it. If you have European, North African, Middle Eastern or Asian ancestors, meaning if your ancestry is not entirely sub-Saharan African, about 2% of your genome comes from Neanderthals. 2% is not a negligible trace, it is tens of millions of base pairs. These are sequences that influence your immune response, your susceptibility to certain diseases, perhaps your sleep cycles, perhaps your pain tolerance. The Neanderthals did not go extinct in the sense we usually understand that word. They didn't simply die, get replaced, outcompeted, erased. They slowly melted away over millennia. Their populations were absorbed into those of Homo sapiens, gradually diluting, leaving this 2% in every cell of every non-African human alive today. The Neanderthals are, in part, still alive, scattered across 7 billion genomes. Before going any further, we must tell a story that says everything about how prejudice can shape science. In 1908, in La Chapelle-aux-Saints, a village in central France, a priest and his 2 nephews discovered the nearly complete skeleton of a Neanderthal in a small cave near the church. It was an extraordinary discovery for the time. The skeleton was sent to Paris, entrusted to the most eminent paleontologist of the day, Marcellin Boule, of the Institute of Human Paleontology. Boule published his analysis between 1911 and 1913, and in this analysis he described the Neanderthal of La Chapelle-aux-Saints as a fundamentally primitive being, knees bent, unable to stand fully upright, head thrust forward like a gorilla, an intelligence barely superior to that of a great ape. He drew a reconstruction. This reconstruction was reproduced in newspapers, encyclopedias, textbooks. It defined the image of the Neanderthal for a century. There was a problem. The skeleton of La Chapelle-aux-Saints belonged to an elderly individual, a man in his 40s or 50s, which was very advanced for the time, who suffered from severe, generalized osteoarthritis. His vertebrae were deformed, his joints worn. Boule had seen the disease and taken it for the norm. The error was identified in the 1950s, then unambiguously confirmed in the 1970s. The Neanderthal of La Chapelle-aux-Saints stood as upright as you do, but the image of the stooped brute had had time to take root. It was in our minds, it was in popular culture, it is still sometimes in corners of our collective memory that the new data hasn't yet reached. The reality of the Neanderthals, as the research of the last 50 years has reconstructed it, is very different. Neanderthals had a brain slightly larger in volume than ours on average, about 1,500 to 1,700 cubic centimeters, compared to 1,300 to 1,500 for sapiens. Their cranial morphology was different, a lower forehead, a deep occipital bun, but their raw capacity was not inferior to ours. They buried their dead for at least 100,000 years, with solid evidence in several sites. Kafse in Israel, Shanidar in Iraq, La Ferracie in France. At Shanidar, an individual found in the 1960s had been buried in what looked like a bed of flowers, with pollen in unusually high quantities around the body. This interpretation has been contested. The pollen might have been brought in by rodents or drafts, but other evidence of Neanderthal burials is robust. They wore jewelry, pierced shells, pierced animal teeth, tinted with ochre or bright yellow, found in Spanish sites dating back over 115,000 years, long before any possible contact with Homo sapiens. They used ochre as a pigment. They perhaps made music. A possible flute found in Slovenia at Divja Bebe is still debated but cannot be completely dismissed. They cared for their wounded and sick. The number of Neanderthal skeletons showing severe healed injuries, consolidated broken limbs, survived cranial trauma necessarily implies prolonged care. An individual does not survive a broken leg in a prehistoric environment without help. And crucially, they shared with us the FOXP2 gene in its modern form. This gene, linked to articulation capacities and language, was identical in its Neanderthal version to the human version. This does not prove they spoke like us. Language is much more than a single gene. But it indicates that their speech anatomy was at least partially compatible. Research published by a team at Princeton in July 2025 mapped 200,000 years of interaction between modern humans and Neanderthals. Not a single episode of contact, but multiple waves, repeated encounters, genetic crossings at different periods in different regions. A long, complex, intertwined coexistence. Neanderthals did not precede us in a simple sense. For tens of thousands of years, we were there together. A question that genomics has recently allowed us to ask with precision: when crossings occurred between Neanderthals and sapiens, who was mating with whom? Data from February 2026, reported in the Washington Post, suggests an asymmetrical pattern. The fathers were most often Neanderthal, and the mothers most often sapiens. It isn't universal, but it is a statistical signal. What that means in terms of social dynamics 40 to 60,000 years ago, we can only speculate. But it gives the encounter a concrete human texture that changes how we perceive it. So why did the Neanderthals ultimately disappear? Or at least, why are there no clearly Neanderthal individuals in the fossil record after about 40,000 years ago? Recent models suggest that direct violence is probably not the explanation, even if episodes of violent competition certainly existed. The model of progressive genetic absorption of Neanderthal populations, already small and fragmented, slowly melting into larger, expanding flows of sapiens populations fits the overall available data much better. Let's think about that concretely. 50,000 years ago, Neanderthal populations in Europe were perhaps 10 times smaller than the arriving sapiens populations. 10 to 1 in terms of sheer numbers. In a context of regular interbreeding over millennia, the Neanderthal genetic signature will mechanically dilute, like a drop of paint in a bucket of water that receives 10 times more. It isn't an extinction. It is a dissolution. The Neanderthals didn't disappear. They scattered into our genomes. And now an image to finish this chapter, because we must put something human beneath all of this. In the Dordogne region of southwestern France, there are limestone gorges where the cliffs are riddled with natural rock shelters. Neanderthals lived in these shelters. They lit fires here. They napped their tools here. Some of them were buried here at La Ferracie, just a few miles from Lascaux. And much later, 30 to 40,000 years after them, Homo sapiens arrived in the same gorges, lit their own fires in the same shelters, painted the walls of Lascaux a few days' walk away. It is highly possible that the artists of Lascaux carried in their cells 2% of the DNA of the Neanderthals who had lived before them in the exact same spot, that they carried something of their predecessors without knowing it, in their biology, perhaps in their immune response, perhaps in something even more diffuse. The Dordogne is perhaps the place where two versions of humanity passed something to each other silently through time. These limestone shelters of the Dordogne, these walls that hosted Neanderthal fires before hosting the paintings of Lascaux, lead us naturally toward something, toward the moment when a human being did something deliberately useless, something that had no immediate survival value. something that served only to express that moment. The first clearly identified artistic gesture is much humbler than you might think. The first drawing in the world looks like a scribble. Those walls in the Dordogne bear some of the most famous paintings in prehistory. But the first known human drawing is not there. It is in South Africa, and it has none of the grandeur of Lascaux. It is 9 red lines drawn with a piece of red ochre on a fragment of rock. The fragment measures about 1.5 inches long. The lines are parallel and crossed, forming a grid pattern, a crosshatch. No bison, no horse, no negative handprints. 9 lines. And they are 73,000 years old. The fragment was found in Blombos Cave on the coast of South Africa, facing the Indian Ocean. The cave is carved into a limestone cliff about 60 feet above the waves. The view from its entrance, when the wind isn't howling into it, must be magnificent. The Indian Ocean stretching out of sight, the waves crashing on the rocks below. It is a place where humans lived intermittently for hundreds of thousands of years. Christopher Henshelwood, a South African archaeologist and director of the Blombos excavations since the 1990s, was working with his team on a batch of fragments collected during a previous excavation campaign. The fragment with the 9 lines was in a crate. It was taken out, examined, put under a microscope, and the lines appeared clearly. Intentional, precise, drawn with application. Published in 2018 in the journal Nature, the Blombos fragment officially became the oldest known human drawing. But what makes it important is not simply its age, it is what it says, or rather what it doesn't say about the act of drawing. Someone 73,000 years ago picked up a piece of ochre, a red iron oxide mineral found naturally in that region of South Africa, and dragged it across a rock's surface, not to sharpen a tool, not to grind a blade, but to leave a mark that had a specific, repeated, organized shape. Why? We don't know. This grid pattern, this crosshatch that other archaeologists have found engraved on blocks of ochre in the same cave, dating back 100,000 years, is not a representation of something in the natural world. It is not an animal, not a landscape, not a human face. It is an abstract pattern, which means the person drawing it had an abstract image in mind, an idea of form, a symbol, perhaps something that didn't physically exist in the environment, but existed in a mental space. That is the very definition of symbolic thought, and it is there in 9 red lines 73,000 years ago. We must mention something here because it is a point of real debate within the community. Is the Blombos pattern necessarily art in the sense we understand it? Some researchers prefer to remain cautious. They point out that we don't know if these lines had a symbolic meaning or if they were simply a test of the tool, an exercise, a functional doodle. It is honest to note that the boundary between the intentionally symbolic and the simply marked is difficult to draw with certainty on a fragment found tens of thousands of years after it was created. What is less debated is the existence of other artifacts in the same cave that together form a clearer picture. Blocks of ochre engraved with similar crossed patterns dating back 100,000 years. Shells of Nassarius kraussianus marine snails, pierced and tinted with red ochre, found in quantities that strongly suggest ornaments, necklaces, or bracelets. 77,000 years ago, workshops for making liquid ochre, a red pigment that someone was deliberately preparing, stored in abalone shells, used for something we can only guess at. Blombos Cave is not a single object. It is a site that, over hundreds of thousands of years, shows human beings manipulating coloured materials, making ornaments, engraving surfaces, beings who had developed a relationship with the visual, with the symbol, with representation long before Lascaux. And yet here is the central mystery. None of this continues in an unbroken line. The pierced shells of Blombos date back 67,000 years. They disappear from the archaeological record for tens of thousands of years before reappearing in Europe, in Asia, in Australia, as if the practice had died out and been reinvented, or had been passed on discontinuously through mobile populations. There is something in this intermittence that is, I find, more unsettling than if everything had been continuous. A continuous tradition from the ochre of Blombos to Lascaux would be reassuring. It would say, once a human being does something, it stays. The capacity catches on and is transmitted. But the intermittence says something else. It says the capacity was there, but its transmission was fragile, that it depended on a group continuing to practice, to teach, to pass the gesture to the next generation, and that when the group disappeared or fragmented, the gesture disappeared with it, not because biology had changed, but because culture is fragile, because it needs living bodies to perpetuate itself. This raises a question I want to leave open. How many times did humanity invent art? Not once, not twice, perhaps 10, perhaps 20, perhaps 100 times in different groups, in different eras, on different continents, before the density and connectivity of populations became great enough for the practice to be transmitted in a stable and continuous way. The art we know, Lascaux, Altamira, Chauvet is perhaps less a beginning than a stabilization. The first time art managed not to disappear. But the first drawing in the world doesn't look like a masterpiece. It looks like someone trying something, someone teaching their own hands what it feels like to leave an intentional mark on a surface. 9 red lines. And someone, somewhere, on the coast of South Africa, 73,000 years ago, looking at what they had just done. This gaze, this moment when a human being observes for the first time what their own hand has left behind, is perhaps one of the most charged moments in all of human history. Not art, not yet, just the act of watching oneself do, of recognizing one's own intention in a trace. Self-awareness, perhaps, or at least its first visible stammering. These 9 red lines, this trace left on the South African coast, say that something was searching for itself in the human mind, something that wanted to express itself, to project itself into the world. But in the same world, on other islands, other human beings were living their own version of this search, isolated by the ocean, transformed by millions of years of insular evolution, becoming something unexpected in their own corner of the world. The forgotten humans of the islands. These 9 red lines on the African coast. The first gesture towards something invisible existed, while thousands of miles away, on islands these draftsmen never reached, other human beings were living an existence we would struggle to imagine. Start with this. Right now, as we speak, as you listen, there are perhaps caves in the forests of the island of Flores in Indonesia that have not yet been excavated. Cavities in the limestone where the bones of a creature rest. A creature that stood about 3.5 feet tall, that knapped tools, that hunted dwarf elephants, and that the local inhabitants called in their oral traditions the Ebu Gogo, the grandmother who eats everything. This creature had a scientific name, Homo floresiensis. And its discovery in 2003 provoked one of the sharpest and most enduring controversies in modern paleoanthropology. It was an Australian-Indonesian team led by Mike Morwood that found the first fossils in the Blombos Cave in western Flores. They were looking for traces of prehistoric human migration toward Australia. What they found instead was someone who wasn't supposed to be there. A skeleton of an adult female, nicknamed Flo by the team, who stood about 3.5 feet tall, weighed perhaps 55 pounds, and whose skull contained a brain of about 380 cubic centimeters, roughly the size of a chimpanzee's brain. She lived with stone tools in a cave with fire, surrounded by dwarf elephants, stegodon, whose bones showed cut marks. She hunted, or at least her kind hunted. She had died there about 50,000 years ago, just about the time Homo sapiens was beginning to arrive in the region. The reaction of the scientific community was initially disbelief. Some researchers, including the Indonesian paleoanthropologist Teuku Jacob, argued that the bones did not represent a new species, but simply a Homo sapiens suffering from pathological microcephaly or dwarfism. This position was fiercely defended for several years, until the accumulation of additional evidence from other individuals and more extensive biometric analyses made the pathological hypothesis increasingly difficult to maintain. What is accepted today is that Homo floresiensis was a distinct species, and that its small size resulted from what biologists call insular dwarfism, a well-documented evolutionary phenomenon in island mammals. When an animal population is isolated on an island, several evolutionary pressures come into play. Resources are limited, large predators are often absent, and smaller individuals have an advantage because they consume less. Over tens or hundreds of thousands of years, bodies shrink. Flores had dwarf elephants. It had giant rats. It had Homo floresiensis. The probable ancestor of Homo floresiensis was Homo erectus, who populated Southeast Asia more than 1 million years ago. A population of Homo erectus, isolated on Flores by a change in sea level or an unfavorable current, slowly evolved into something smaller, something more adapted to this particular environment. It is one of the most spectacular and soberly elegant evolutionary paths known in the human lineage. But here is what is most unsettling about the story of Flores. There is no DNA. The humid heat of Indonesia destroys DNA molecules in a few tens of thousands of years. No genome of Homo floresiensis will likely ever be sequenced. Its genetic history, its relatives, its migrations, its relationships with other populations remain closed. We have its bones. We do not have its molecular biology. It is a limit that applies to many tropical and subtropical human species. The window of ancient genomics does not open in the same regions of the world. It works well in the cold caves of Siberia. It works less well in the tropics. This geographic bias profoundly shapes what we know and what we do not know about the distribution of prehistoric humanity. In 2019, a second insular surprise arrived from the Philippines. Florent Détroit, a paleoanthropologist at the National Museum of Natural History in Paris, led the team that described Homo luzonensis, a new species found in Callao Cave on the island of Luzon, the largest island in the Philippines. The teeth, foot bones, and hand bones dated back at least 57,000 years. The individual, or individuals, measured less than 4 feet tall. What made Homo luzonensis particularly baffling wasn't its size, it was its anatomical mosaic. Its teeth had dimensions similar to those of modern Homo sapiens, but its foot bones resembled those of Australopithecus africana beings who had lived more than 2 million years ago on the other side of the world. Its curved finger bones also recalled very archaic forms. And yet this being was there on Luzon relatively recently. How did it get there? What lineage connects it to the African Australopithecus or the Asian Homo erectus? Dutoit and his team published their conclusions with exemplary caution. They didn't yet know exactly what these fossils meant. They only knew that they didn't fit into any existing box. Homo luzonensis is an anatomical mystery still wide open. What Flores and Luzon show together is something important about the plasticity of humanity. Give a human population a few 100,000 years of isolation on an island, and it can become something quite different from what it was. Not an aberration, an answer, an evolutionary solution to a specific problem posed by a particular environment. The human form is not fixed. It is plastic. It responds to pressures. On an island, the pressures are different, so humanity responds differently. There is something melancholy in the isolation of these island humans. Homo floresiensis on Flores, perhaps for 1 million years, perhaps more. Homo luzonensis on Luzon, living, hunting, dying, passing down knowledge for entire millennia without ever knowing that somewhere beyond the horizon other beings existed who looked vaguely like them, who carried perhaps different tools, different words, different ways of facing the night. Insular evolution is a profound loneliness. Tens of thousands of years adapting to a world that only exists as far as the coast. And the oral traditions of the current inhabitants of Flores, the Ibu Gogo, this grandmother who eats everything, who ran in the forests before the first modern humans arrived, are perhaps an echo of that encounter. A cultural memory passed down over 50,000 years, distorted, mythologized, but perhaps carrying something of a real memory. It would be extraordinary if it were true, and even if it isn't entirely true, even if the Ibu Gogo is simply a myth with no documented link to Homo floresiensis, what it says about how human beings keep the traces of their encounters with the strange is remarkable in itself. Memory seeks a shape. It finds the story, and the story, for millennia, holds on to a piece of a past that no bone alone can tell. These beings isolated on their islands, napping their tools, hunting their dwarf elephants, knowing nothing of what was happening beyond the horizon, lived in a world already heavily populated by different versions of humanity. And all these versions had, in one way or another, a certain capacity to communicate with each other within their groups. But the most sophisticated form of this communication, articulate, symbolic, narrative language, remains one of the least resolved enigmas in all of human prehistory. Language, the oldest thing you are doing right now. These isolated islands, these reduced humans, these improbable anatomical mosaics, all lived in a silence we cannot hear. We can see the tools. We can see the bones. We cannot hear what was said around the fires, nor what was passed from one generation to the next. Because there is nothing more invisible in prehistory than language. What you are doing right now, listening to words and building meaning from them, following a narrative, holding on to one idea while the next arrives, and connecting what I said 10 minutes ago to what I am saying now, is one of the most complex cognitive operations that exists. No other animal does it at this level, and yet you do it effortlessly, lying in the dark, half asleep. When did that begin? The honest answer is we do not know with precision. But the contours of the enigma are now well enough defined to see where the darkness lies. Here is what we know with reasonable confidence. About 2 million years ago, Homo habilis was making stone tools, Oldowan tools, which required a transmission of learning. Not necessarily articulate speech, but at least a form of communication precise enough to teach how to hold a flint, how to orient it, and how to strike at the right angle. Even capuchin monkeys can learn to crack nuts from their peers through observation and demonstration. No language required for that. About 1.5 million years ago, Homo erectus was making Acheulean tools, symmetrical hand axes worked on both sides, which demand multi-step planning and a form of mental representation of the object before it is made. Some researchers believe this implies a form of language, even a rudimentary one. Others are more cautious. Then there is the FOXP2 gene. FOXP2 was discovered in the early 2000s by studying a British family in which a mutation of this gene caused severe difficulties in producing and understanding language. Articulatory disorders, an inability to string together complex mouth movements. Grammatical difficulties. The gene therefore clearly had a role in the neuromuscular mechanisms of language. What followed was one of those discoveries that looks at first like an answer, but turns out to be an even deeper question. In 2007, researchers sequenced the FOX2 gene in Neanderthal fossils, and they found that Neanderthals carried exactly the same version of the gene as modern humans. The same 2 mutations in the same positions that distinguish the human version from the chimpanzee version, which suggests that Neanderthals, and probably their common ancestors with us some 500 to 700,000 years ago, already had the molecular architecture linked to the articulate production of language. The anatomical structures of speech were in place for perhaps 500,000 years. And yet behavioral evidence of complex symbolic narrative language doesn't seem to date back 500,000 years. It seems much more recent. An important clarification here. FOXP2 is not the language gene in the sense that possessing this gene guarantees the ability to speak. Language involves hundreds of genes, thousands of neural connections, cortical structures of a complexity we are only just beginning to map. FOXP2 is one piece of an extraordinarily complex mechanism. The fact that Neanderthals shared it tells us something about their potential articulatory capacities, not necessarily about the richness or complexity of what they communicated. In March, a team from MIT published a comparative genomic analysis that proposed a minimum date for the emergence of linguistic capacity in modern humans. 135,000 years ago. That is the date when the genetic variations associated with language processing seem to have become fixed in the ancestral population of all living humans. 135,000 years. And yet the first solid archaeological evidence of a complex and symbolic language in action, elaborate communication systems visible in the complexity of tools, ornaments, and long-distance trade of specific objects, dates instead to 50 or 60,000 years ago. There is a gap of 75 to 85,000 years between the moment the capacity seems acquired and the moment it becomes fully visible in the records. What happened during those 80,000 years? There are several hypotheses. Perhaps language existed, but remained limited in complexity. Efficient communication systems for the immediate needs of the group, but not yet capable of transmitting complex abstractions. Stories about the past and future fictions. Perhaps the leap to this higher level of linguistic complexity required a critical mass of population and connection between groups. That rich narrative language emerges in networks, not in isolated individuals. Perhaps full language capacities existed for 100,000 years, but the social contexts where they fully deployed only appeared later. There is a profound debate here between two fundamentally different visions of the evolution of language. The first, sometimes called the syntactic revolution thesis, argues that at a given moment, a qualitative change occurred in the way humans combine sounds into structures. The acquisition of recursion, the ability to nest clauses inside one another infinitely, the man that the woman that the child had seen knew had left. This would have been the decisive leap, a mutation or neural reorganization that paved the way for bottomless grammatical complexity. The second vision, defended notably by researchers like Michael Tomasello, argues that recursion is not a specific biological property, but the result of general cognitive capacities combined with sufficient cultural pressure. In this view, language is less a biological mutation than a cultural technology, something that was built progressively, layer by layer, over tens of thousands of years of collective use. Both camps have arguments and data and the truth. As is often the case in science dealing with such vast timescales, probably lies somewhere in that uncomfortable space between the two. There is one thing I want to leave you with before moving on. Right now, as you listen to these words, your brain is doing something extraordinary. It is segmenting the stream of sound into distinct units. It is assembling those units into morphemes, into words, into clauses. It is activating a representation of the meaning of each word, relating it to the previous ones, building a syntactic structure, extracting an overall meaning, integrating that meaning into what it already knows, anticipating what will come next. All of this in real time, without conscious effort, at the speed of speech. And this capacity, this thing you do so naturally that you never even think about it, is perhaps the oldest thing you possess. Perhaps 150,000 years old. Perhaps more. Listening to a voice in the dark before sleeping is perhaps as old as language itself. Language allows us to narrate the present, but also the past and the future. The things that aren't there, the people who are no longer there, the events that happened elsewhere and long ago. This power of transmission across time and space raises one last question that language alone cannot resolve. What happens to those who leave, to those who cross the known horizon, to those who disappear without leaving a trace in anyone's memory? The first Homo sapiens who left Africa more than 100,000 years ago disappeared in this way, without genetic traces, without known descendants, as if they had never been there. The first to leave, and those who left no trace. Language allows us to recount the absent, but some absents have vanished so completely that no language has retained them. Not even in the genes. Here is a fact that should trouble us more than it does. Over 100,000 years ago, perhaps 200,000 anatomically modern human beings left Africa. They crossed the Sinai or the Strait of the Red Sea during a time of low sea levels. They reached what is today Israel and the Near East. They lived there. Their bones were found. And then they disappeared. Entirely. Not a migration that succeeded, not a population that merged with others and diluted. A clean, complete disappearance, leaving no trace in the genomes of any living populations today. The site of Mislia Cave in Israel yielded fossils of Homo sapiens in 2018, dating back at least 177,000 years. anatomically modern individuals, recognizable sapiens, living in a region that is today at the heart of the cradle of early agricultural civilizations, 100,000 years before the Egyptian or Mesopotamian civilizations. This group is not in your genome. The great exit from Africa, the one from which all non-African humans living today descend, is much more recent. It dates to about 60 to 70,000 years before our era. That is the one that populated Eurasia, Australia, the Americas. That is the one you are the product of. But it wasn't the first attempt. There had been earlier exits, at least one represented by the fossils of Israel, which left no descendants. What happened to these pioneers, we do not know. A few hypotheses emerge. The simplest, unfavorable climatic conditions in the Near East may have decimated the populations established there. A cooling, a drought, a series of bad years. A population of a few hundred or a few thousand individuals is extremely vulnerable to environmental disruptions. Another possibility. These groups may have encountered other human populations, Neanderthals perhaps, other species that already occupied the regions they were trying to reach, and the competition for resources worked against them. Or perhaps, and this is the most unsettling possibility, they left genetic traces somewhere that we simply haven't identified yet. Population genomics is a young science. The models are refined every year. What seemed like a total disappearance in 2020 might reveal a subtle signal in 2030. But for now, they left, they lived, they disappeared. There is something in this story that resonates in a particular way. Think of this pioneer group, perhaps a few hundred people, perhaps a few thousand, who left Africa over 100,000 years ago, who walked north, crossed deserts, followed coastlines, found a fertile region by the sea, who established something, fires, camps, perhaps practices and ways of doing and saying things, who had children there, who buried their dead there, and then silence. No known descendants. No genetic thread we can follow to a human living today. It is possible that other groups in other regions met the same fate. That the history of humanity is littered with these aborted attempts. Populations that existed for tens of thousands of years, that developed cultures, languages, perhaps arts, that were erased by time, climate, competition, chance. The Great Migration of 60 to 70,000 years ago, the one that worked, the one you are the result of, wasn't necessarily superior to previous attempts. It perhaps simply happened at the right time and in the right climatic conditions, with a population large enough to reach a critical mass. Luck again. But there is something else in this history of multiple exits from Africa that deserves attention. The most recent genomic analyses suggest that the Great Migration of 60,000 years ago was perhaps not a single, simple event either. There were perhaps several waves, several groups leaving at slightly different times, merging and separating again in the regions they crossed. Humanity didn't spread across the planet like an even stain of oil. It spread like a river seeking its path, finding passages, retreating from obstacles, taking unforeseen forks, leaving dead branches. Some of these dead branches are in the fossil record, fossils without descendants. Others are perhaps still in the ground somewhere, waiting to be found. And still others, perhaps, left no bones at all, just a temporary presence in a landscape that erased them. A footprint in the mud. What the fossils of Israel, combined with current genomics, ultimately tell us is that human history is full of dead ends, of doors that open and close, of human adventures that lasted tens of thousands of years and are today visible in no genome, in no memory, nowhere, except in 2 or 3 fragments of bone beneath the sediments of a Near Eastern cave. These people had names, or at least something that played the role of names. They had ways of saying rain fire, hunger joy. They had stories about the past that they passed down to their children, and all of that is gone without a trace, except these few bones that only tell us we were here. And yet, and this is perhaps the most remarkable thing of all that we have covered tonight, science continues. It finds new ways to read what the past thought it had erased. It extracts genomes from cave dust. It connects forgotten fossils in drawers. It builds genomic models that bring ghost populations into view. Every year, something we thought was lost returns. And it is toward this idea and toward what it says about who we are that we will go to finish. What science still cannot explain, and why that is good news. These people of Mislia who left no descendants, this silent disappearance brings us back to something central, to the question that structures everything we have journeyed through tonight. What exactly is the prehistoric void? We have spent these hours looking at gaps, silences in the records, species without fossils, populations without faces, behaviors without clear explanations, migrations that left no genetic trace. A drawing of 9 red lines that appears out of nowhere and disappears for millennia. An orange-sized brain that perhaps buries its dead. A pinky fragment that contains an entire species. One could conclude that prehistory is disappointing, too full of gaps, too uncertain, too full of what we don't know to be truly satisfying. I want to suggest the opposite. The prehistoric void is not a failure of science. It is the proof that the reality of the human past is far richer, far more complex, far stranger than anything we had imagined, and that the open questions are exactly where the next revolution is waiting. Let's go back to what we didn't know 25 years ago. We didn't know the Denisovans existed. We didn't know Neanderthals had contributed to our genomes. We didn't know Homo sapiens lived in Morocco 315,000 years ago. We didn't know a human species standing 3.5 feet tall lived in Indonesia 50,000 years ago, nor that an even smaller one lived in the Philippines at the same time. We didn't know a mystery population had contributed 20% of our DNA. 3 years ago, we didn't know a species with an orange-sized brain might be burying its dead. All of that in 25 years, less than a generation. What does that say about what we will discover in the next 25 years? There is something important to understand about the mechanics of this acceleration. Classical paleoanthropology, the science of fossils, of bones, of morphology, is a discipline 1.5 centuries old, since the first Neanderthal bones were described. It progressed slowly, bone by bone, excavation by excavation, drawing conclusions from rare and difficult-to-date fragments. Then ancient genomics arrived, and it changed the rules of the game in a way that hasn't even been fully measured yet. Svante Pääbo, by sequencing the DNA from the Denisovan Pinky in 2010, opened an entire world that was invisible to morphology. We can now detect populations that left no recognizable bones. We can map crossings that took place without any known human witness. We can, under certain conditions, extract genomes directly from the sediments of a cave without any bone at all, and find the trace of populations who slept there tens of thousands of years ago. A revolution as important in its field as the telescope was in astronomy. Suddenly, the sky contained far more than what the naked eye saw. Suddenly, prehistory contains far more than what fossils alone could show. And just like after the invention of the telescope, the first reaction is vertigo. All these worlds we never suspected. Let's gather the threads of tonight. 315,000 years ago, someone in Morocco was making flint tools and perhaps looking at the same sky as you. Their skull bone survived in a mine, was almost pulverized by dynamite, slept in a drawer for decades before anyone understood what it was. 240,000 years ago, a being with a brain a third the size of yours perhaps descended into a cave in South Africa to lay a dead body to rest. We don't know yet if it's true, but the question is seriously being asked. 170,000 years ago, a group of sapiens lived in Israel. They left no known descendants. They simply walked away into silence, into time. 60,000 years ago, a Denisovan girl in Siberia left a pinky fragment in the floor of a cave. That fragment contained enough information to reveal an entire species. 73,000 years ago, someone in South Africa drew 9 red lines on a fragment of rock and looked at them. 50,000 years ago, Neanderthals began to melt into sapiens populations, and 2% of them still lives in every non-African human being right this moment. 300,000 years ago, a mystery population merged with our ancestors and gave them 20% of their DNA. This population has no face, it has no name. It is in your cells right now. All of this is real. All of this is documented with varying degrees of certainty, with ongoing debates, with questions that are open but real. And all of this was unknown a generation ago. There is a question I want to ask because it seems to me the most important of all the ones we have crossed tonight. Not a question about paleoanthropology, a question about what all of this means for you right now, in this moment. You are lying in the dark. You are listening to a voice before sleeping. How many times has that happened, not in your life, in human history? How many thousands of nights, for how many thousands of years have beings who looked like you done exactly this? Lying down, closing their eyes, letting a voice or the crackle of the fire, or the sound of the wind in the trees carry them towards sleep, keeping watch over them. Moments when human groups gathered in the evening, when stories were told, when children fell asleep listening to adults talk about things they didn't entirely understand, are not a recent invention. They are perhaps as old as controlled fire, perhaps 400,000 years, perhaps more. Oral transmission, the voice carrying knowledge to someone drifting off to sleep, is perhaps the oldest form of human culture. It precedes writing by at least 200,000 years. It is the way most human knowledge has travelled for almost the entirety of our history, from one generation to the next. What you are doing tonight is not modern, it is not digital, not technological in its essence. It is a very, very old thing. And there is something gentle in that thought. Something that connects this moment, you in the dark, listening to all those other moments that followed one another for tens of thousands of years. Other ears in other darknesses, other voices carrying other stories toward other slumbers. The question of the prehistoric void remains open. It will remain so for a long time yet, perhaps always in part. Because some things humans thought, felt, and created will never leave a trace that science can read. The beauty of a night sky seen by someone 100,000 years ago is gone without leaving a signal. The name a mother gave her child in South Africa 200,000 years ago is gone with her. But the bones remain. The DNA sometimes remains in cold caves. And the questions we ask of the past, the good questions, the questions that disturb established certainties, eventually produce answers no one expected. That is the prehistoric void, not a lack, an invitation. Settle in where you are. The room around you is quiet now, or almost. There might be a sound outside, a car, the wind, something distant. Your body is starting to weigh a little more into the mattress. Your eyes are closed, or almost. And in your cells right now, there is something that belongs to Neanderthals. Something that belongs to a population whose bones we have never found. Perhaps a tiny trace of a lineage that died out before anyone thought to give it a name. Your body is a palimpsest. Several stories written one over the other, most of which are unreadable, a few of which are only just beginning to be deciphered. You are not the result of a straight line. You are the result of an immense bush, almost all of whose branches have disappeared, of countless encounters between beings who perhaps didn't fully understand each other, who lived under skies, who carried different tools, and who still recognized each other enough to pass something on. That something is you. Let that thought settle gently. There is nothing to retain, nothing to memorize. These stories have already made their way. They have slipped into the darkness between the words, between the sentences, and they are there now, quiet in the dim light of what you know about yourself. Somewhere in a cave in Siberia, dust rests on sediments 60,000 years old. Somewhere in Morocco, bones sleep in a limestone rock under the sun. Somewhere in South Africa, 9 red lines on a fragment of silkreed wait in a museum crate for someone to look at them again, and you here are falling asleep. That is perhaps the simplest and truest thing prehistory tells us. Human beings have always ended up lying down and closing their eyes, and no matter the century, no matter the continent, no matter the species perhaps, the night comes, the body yields. And if you want to share where you are listening from tonight, New York, California, Texas, the UK, Australia, or any other corner of the world, leave a comment. I am genuinely interested to know where these words are landing. And if you want others to find nights like this one, subscribing helps more than you might think. But for now, none of that is rushed. Let your breathing slow down. Someone 73,000 years ago pressed a piece of red ochre against a rock and drew 9 lines. They looked at what they had just done. And then, because the night had come, because the fire was burning low, because the body was asking for what all bodies eventually ask for, they lay down and they slept. Good night.